that's sort of just very recently started to catch on. So it's an idea from actually back from the 70s, which is thought about how you can actually test the quality of a test suite. So these days, most people are doing things like peer review or using code coverage or often doing TDD. So they sort of assume that as a result of this, I have good tests and I've got high coverage, or someone's checked it for me. It looks like this test looks good, or hey, I wrote the test first, it must be good. Turns out when you sort of come to look at these things that actually maybe you're being a little bit overconfident. So there's this technique from the 70s that actually will tell you a pretty definitive answer whether or not your tests are good. It's actually a really, really simple idea. All you do is you deliberately introduce a bug into your code.
Yeah.
Run the test suite.
Make sure it detects it.
Yes, if the test suite fails, then you've caught the bug. That means it's a good test suite. If it doesn't fail, then something might be wrong.
Yeah, that makes sense. But how do you introduce bugs into the code?
Well, you can do it yourself, and some people in fact do that on purpose sometimes, sometimes not. That doesn't scale so well, so you've got a million-line program trying to introduce bugs throughout it to see you test it and find them. Well, you're not going to get very far. And if you think about it sort of theoretically, however you do it, even you can put a bug in just like that, then if you have a test suite that takes, 10 seconds to run, and let's face it, many test suites take much longer than that.
Yeah, I've had test suites which have taken hours to days.
Hopefully not a unit test suite. So unit tests, most people try to keep them under 5 minutes for a really large code base. Obviously, other sorts of testing may go on top of that and take much longer. But unit tests, usually talking seconds or minutes.
Hopefully.
But imagine you want to put, you've got a large code base to try and actually put a lot of meaningful bugs in there to actually really know whether or not you could you'd find them. You're looking at tens or hundreds of thousands of bugs. Yep. Multiplied by the time of your test suite, you're looking at hours, weeks, days to analyze the code base. So this was, the technique seemed very interesting. It was academically interesting. It was studied for 40 odd years.
But just not practical.
And one of the reasons being the performance. Some other reasons as well, but maybe I have time to discuss just now. So a few years ago, I got interested in this. I was a bit bored, to be honest, and it seemed like an interesting problem, and started having a play around. We started to sort of think about it. Actually, the problems aren't really unsurmountable. So I produced an open source project called pitest, which for something say like Joe at a time, if you go through the brute force method, you'd be looking at about 2 days to analyse Joe at a time based on its test suite and of mutants. Pitest does it in about 3 minutes. That's
pretty good.
It's a reasonable improvement, I think, and because it's practical, because it's usable, people start to use it. So I've now found that all over the world there are places now mutation testing their code. It's becoming, I wouldn't say popular. It's still quite a niche thing.
Well, but probably for organizations and businesses which really need to know that their test suites are high quality, are actually catching meaningful bugs and.
I think you'd be hard-pressed to find a business or developer who says it's not important their test suite was high quality. The consequences might be different.
Maybe it depends on what the ramifications are if your tests are not telling you what you want.
Yeah, I think on an absolute scale, I think some people are much more right to believe that their test suites need to be pretty high quality. Yeah. But if your business goes bust, you're probably personally quite upset, even if you haven't killed anybody. So because the cost is now much lower, it doesn't really matter. So then we've got high-profile guys like CERN with the Large Hadron Collider using pitest, and
that would have a high risk of failure.
But the other end we have tractor manufacturers, people doing tractor sales, banks, just every common day software. So the barrier to using it is relatively low. So why not use it?
Yeah, that's cool. So we were looking at this earlier, but it looks like you have a project website at pitest, pitest. Was it org or com?
.org. That's right.
.org. Yeah. And it's an open source project.
It's open source, yes.
So folks can just download it and give it a try.
Absolutely. So it integrates with almost everything. Got Maven 2 plugin, Gradle plugin. There's an AMP plugin. Not that many people use it. I think there's Eclipse integrations, Sonar plugin. It integrates with most of the sort of Java ecosystem.
And how hard is it to set it up and integrate it with random projects?
If they're built with Gradle, often you have to do nothing at all. It aims to be zero config. It might not work for you with zero config, but if you have to put something in the POM, then it's like any of the Maven plugin.
Cool. Okay. Sounds exciting. So looking forward to hearing more about the project. Thanks for the very short interview.
Oh, thank you.
For folks watching the live stream, you can watch the recordings at nighthacking.com and then interact with us by tweeting to #nighthacking. So thank you very much.
Thank you.